Hello friends, in previous lecture we have to discussed about relative motion and specifically one-dimensional relative motion and the solved problems of relative motion and specifically one-dimensional relative motion. So today we are continue with the one-dimensional relative motion and the problems with the one-dimensional relative motion. So let us start with the problem number 9. So problem number 9, a police van moving on a highway with a speed of 30 km per hour fires a bullet at a thief's car speeding away in the same direction with a speed of 192 km per hour. If the muzzle speed of the bullet is 150 meter per second, then with what speed does the bullet hit the thief's car? So from the first sentence, a police van is moving on a highway with a speed of 30 km per hour. So here, a police van this is a police van and it is moving with 30 km per hour. Fires a bullet at thief's car speeding away in the same direction with a speed of 192 km per hour. So thief's car is moving in the same direction. This is positive x direction and this is also positive x direction with 192 km per hour. If the muzzle speed of bullet is 150 meter per second, so here a bullet is fired from the police van with 150 meter per second. So with what speed does the bullet hit the thief's car? So ultimately we have to find the speed of hitting VH. Now here velocity of police van, that is 30 km per hour, that means 30 into 1000 divided by 3600, so it will become 25 by 3 meter per second. Now the velocity of thief's car, that is Vt, it is 192 km per hour, that means 192 into 1000 divided by 3600, so it will become 160 divided by 3 meter per second. Velocity of bullet, that is Vb, 150 meter per second. Now the total velocity of bullet, it will become velocity of police van plus velocity of bullet. So velocity of bullet, it is already consist of velocity of police van. So it will become 25 by 3 plus 150. So 3 into 150, 450 plus 25, 475 divided by 3 meter per second. Now the velocity of hitting that is VH is equal to, so the velocity of hitting VH is equal to velocity of bullet, that means the total velocity of bullet, that is 475 divided by 3 minus the velocity of thief's car, that is Vt, 160 divided by 3. So it will become 315 divided by 3. So velocity of knitting VH is equal to 105 meter per second. So this is a answer. So next problem, problem number 10. Two trains A and B are 100 km apart and traveling towards each other on different tracks with starting speed of 50 km per hour for both. The train A accelerates with 20 km per hour square and train B retards with 20 km per hour square. Now find the distance covered by train A when they crossed to each other. So here, in case 1, two trains A and B are 100 km apart. So here, train A, this is a train A, this is a train B, both are 100 km apart. So initial separation is 100 km and both are traveling towards each other. So both are traveling towards each other. So direction of both are opposite. This is in positive direction and this is in negative direction. And the initial speed of both, that is 50 km per hour. So now we have to find out the distance covered by train A when they are close to each other. So here, a relative velocity of train A with respect to B, that is VA minus VB. So VA is 50 minus VB in the opposite direction 50, so it will become 100 km per hour. So here it is the initial speed, so we can say that UAB is 100 km per hour. Now train A is accelerates with 20 km per hour and train B is retards with 20 km per hour. So in case 2, here it is a train A, here it is a train B. The direction of both is opposite. Train A is accelerates with 20 km per hour square and train B retards. So the direction of train B is in negative direction. So the retardation is in the positive direction. So train B is retards with the 20 km per hour square. So here relative acceleration of A with respect to B is acceleration of A minus acceleration of B. Acceleration of A is 20 minus acceleration of B is also 20. The direction of both is same in positive direction. So it will 20 minus 20 becomes a 0. Now the relative separation, the separation of A with respect to B is velocity of A with respect to B into t plus 1 by 2 acceleration of A with respect to B into t square. So it will becomes 100 UAB, that is 100 t plus 0, because acceleration of A with respect to B is 0. So t is a distance covered by A. So distance covered by A is UA into t plus 1 by 2 AA into t square. So here UA is 50, T1 plus 1 by 2, acceleration 20, t1. So ultimately distance covered by A is 50 plus 10, so 60 kilometers. So distance covered by A, it will become 60 kilometers. Question 11. Two cars get closer by 9 meters every second while traveling in the opposite direction. They will get closer by 1 meter every second while traveling in the same direction. So what are the speeds of that cars? So from the first sentence, two cars get closer by 9 meter every second while traveling in opposite direction. So here this is a car A and this is a car B. Both are traveling in the opposite direction. So it is positive direction and negative direction. So here from the first sentence, two cars get closer by 9 meter every second while traveling in the opposite direction. So here a relative velocity of car A with respect to B, that is VA minus VB, that is delta S divided by delta T. Ultimately VAB, that is delta S by delta T. Here both the cars are moving in the opposite direction, so it will becomes VA minus VB, so it will becomes as a VA plus VB. Now the distance covered by every second, that is 9 meter. So here VA plus VB is equal to 9 by 1 is equal to 9. So VA plus VB is equal to 9. This is the equation number 1. Now from the second sentence, they get closer 1 meter every second while traveling in the same direction. So now this is car A and this is car B. Now both are moving in the same direction. Both are moving in the same direction. So at that time a relative velocity VAB, the velocity of A with respect to B, that is VA minus VB, because both are moving in the positive direction. So VA minus VB, that is delta S by delta T. So in this case delta S is 1 and delta T is 1. So VA minus VB is equal to 1. So this is equation number 2 and this is equation number 1. Now from the equation number 1 and 2, here equation number 1 plus equation number 2, it will become 2 VA is equal to 10. So VA is equal to 5 meter per second. So now VA plus VB is 9, but VA is 5. So ultimately VB is 4 meter per second. So our answer is VA is 5 meter per second and VB is 4 meter per second. So this is an answer. Now next problem. A jet airplane is traveling from east to west at a speed of 500 km per hour eject out the gases of combustion at a speed of 1500 km per hour with respect to jet plane. Now what is the velocity of gases with respect to an observer on the ground? So here first question 12, the sign convention of the direction, that is north, south, east and west. This is a standard sign convention of the direction system. Now from the first sentence, a jet airplane traveling from east to west at a speed of 500 km per hour. So one jet airplane is traveling from east to west by 500 km per hour. Now it ejects out a gases of combustion at a speed of 1500 km per hour with respect to jet plane. So here a gases of combustion, that is, comes out from the jet plane and it is having a velocity 1500 km per hour with respect to the velocity of jet. So it is a relative velocity. Now we have to find out the velocity of gases with respect to an observer on the ground. So that means we have to find out the absolute velocity of the gases, that means Vg. Now the velocity of jet plane, that is Vj, that is 500 km per hour. Now the relative velocity of gases with respect to jet, so relative velocity of gases with respect to jet is equal to 1500 km per hour. So now velocity of gas with respect to jet, that is Vg minus Vj. So velocity of gas with respect to jet, that is a subtraction of velocity of gas minus the velocity of jet. So velocity of gas with respect to jet, that is 1500. Now the velocity of gas, that is Vg. Now the direction of jet, that is in the negative direction, and the direction of this gas, it is in the positive direction. So here minus Vj, the velocity of jet, that is 500, but it is negative. So 500. So it will become 1500 Vg plus 500. So the absolute velocity of gas, or the velocity of gas with respect to observer, that is 1000 km per hour. Well, now let me discuss about a relative motion in two dimension. So relative motion in two-dimensional relative motion, there is sign convention. First is a sign convention of direction. So as per the direction, here north, south, east and west. So as per the Cartesian coordinate system, we have a x-axis and y-axis. This is I caret, j caret. The unit vector in the x direction, that is I caret, unit vector in the y direction, that is j caret, unit vector negative y direction, that is minus j caret, and unit vector in the negative x direction, that is minus I caret. So in two-dimensional relative motion, we have to consider a direction as well as the magnitude. And ultimately, for finding a resultant, we have to follow for resultant if the angle between 90 both the vector, then we have to find out a resultant by Pythagoras theorem, and otherwise if the angle is not equal to 90, at that time we have to use a law of parallelogram for finding a resultant. That means if it is A and B, then the resultant of A and B that we have to find out from Pythagoras theorem, because the angle between both the vectors are 90 degree. If the angle is not 90, then we have to find out a resultant with a law of parallelogram. So this is two-dimensional relative motion, and the various kind of two-dimensional relative motion problems are two-dimensional relative motion problems, then river main problems, then rain main problems, so question 13, a car is going eastward with velocity of 8 km per second. To the passengers in the car, a train appears to be moving in northwards with a velocity of 15 meter per second. What is the actual velocity of train? Now from the first sentence, now it is a problem of relative motion in two dimension. So it is a problem of relative motion in two dimension. Here a sign convention of direction, that is north, south, east, west. So a car is going eastward with a velocity of 8 km per second. So a car is going eastward with a velocity of 8 meter per second. Here it is a car. To the passenger in a car, a train is appeared to be moving in northward with a velocity of 15 meter per second. So a train is moving, this is train, this is car, with 15 meter per second. So it is a relative velocity, because here to the passengers in a car, a train is appeared to be moving in northward direction. So as a perspective of the passenger, it will become a relative. So ultimately we have to find out what is the actual velocity of train. So ultimately we have to find out velocity of train. Now here this is a two-dimensional relative velocity problem. So here we see the velocity of car, it is in the positive x direction, so it will become 8 I caret. The relative velocity of train with respect to car, that is a v t c, it is 15 j caret because it is in positive y direction. So now ultimately we have to find out a velocity of train. So now here velocity of train with respect to car, that is v t minus v c. So vtc, that is 15 j caret, is equal to vt minus vc. So velocity of car vc, that is 8 I caret. So now vt is equal to 8 I plus 15 j caret. So velocity of train, the magnitude of velocity of train, that is under root 8 square plus 15 square. So it will become a 17 meter per second. So Vt, velocity of train, that is 17 meter per second. And the vector representation of this problem, that is, it is 8I 15J, and the law of parallelogram, if we complete the parallelogram, then the velocity of train Vt, it will become 17. So ultimately the velocity of train, that is 17 meter per second. So it is a problem of a two-dimensional relative motion. So it is the first problem of two-dimensional relative motion. So in two-dimensional relative motion, we have to consider magnitude as well as the direction. So here we can use vector products or the laws of the vector algebra. So question 14, a helicopter is flying in south direction with a speed of 50 km per hour, and a train is moving with same speed towards east. Now find out the relative velocity of helicopter as seen by the passenger in the train will be towards in which direction. So from the first sentence, a helicopter is flying in south direction with a speed of 50 km per hour. So as per the direction system, that is north, south, east and west, a helicopter is flying is in the south direction. So VH, that is 50 km per hour. Now a train is moving with the same speed towards east. So a train Vt is moving towards east. So it will positive x and that is negative y. Speed is 50 km per hour. So here a velocity of helicopter, that is minus 50 j caret because it is in negative y direction, and the velocity of train, that is 50 I caret because it is in positive x direction. So now ultimately we have to find out a direction of VHT. So VHT, that is VH minus VT. So here VHT, that is velocity of helicopter with respect to train. So VH is minus 50 j caret minus Vt. Vt is 50 into I caret. So as per the vector representation, here we have to represent the vector Vht. So it is minus 50I minus 50j. So here it is minus 50I minus 50j. So as per the law of parallelogram, the resultant vector Vht, which is in the direction of southwest or third quadrant. So the direction of Vht, it is in the southwest, and the magnitude of Vht, that is under root 50 square plus 50 square, so it will become 50 root 2. So ultimately our answer is the southwest. Question 15. Two particles are moving with velocity of v1 and v2. The relative velocity is the maximum when the angle between their velocity is. Now, from the first sentence, two particles are moving with velocities v1 and v2. So here two particles, we have to assume that two particles are moving with velocity of v1 and v2. Now we have to assume that the relative velocity is maximum. Now we have to find out the angle between the velocity v1 and v2. So now the expression of maximum velocity or maximum relative velocity, here A and B both are particles. Now the relative velocity of A with respect to B, that is VA minus VB, but VAB is maximum. At that time VAB maximum, that is VA plus VB. Now VAB maximum, that is VA minus VB. So from this expression, particle A is moving in positive x direction and particle B is moving in negative x direction. So here VB and VA. So VA minus VB. So the angle between both the particle, that is 180 degree or pi radian. So our answer is 180 degree or pi radian. Now next question. A ship is traveling to east at 10 km/h. A second ship is heading 30 degree east to north. Now find out the speed of second ship. So here from the first sentence, here a ship is traveling to east with 10 km/h. So here question 16, the sign convention of direction, that is north, south, east and west. A ship is traveling to east with 10 km per hour. So first ship is traveling to the direction of east with 10 km per hour. Second ship is heading 30 degree east to north. Now second ship is heading from north to east 30 degree, that is VB. So now this angle is 60 degree. So now we have to find out the speed of second ship. So here if we complete that triangle, then we have to find out the speed of that second ship, that means VB. So here cos 60, that is VA divided by VB. Now cos 60 is 1 by 2, VA is 10 divided by VB. So here VB is 20 km per hour. So the speed of second ship, which is towards east from the 30 degree to north, that is 20 km per hour. Now next problem, question number 17. Two billiard balls are rolling on a flat table. One has a velocity component Vx 1 meter per second and Vy root 3 meter per second, and another has a component Vx 2 meter per second and Vy 2 meter per second. If both balls are start moving from the same point, then what is the angle between their path? So here from the first sentence, here two billiard balls are moving in the flat table with velocity component. So for first it is Vx1, it is 1 meter per second, Vy1 is equal to root 3 meter per second. For second ball Vx2, it is 2 meter per second, Vy2 it is also 2 meter per second. Now we have to find out a relative velocity and the direction of that relative velocity. So here delta Vx is equal to Vx1 minus Vx2. So Vx2 minus Vx1 means 2 minus 1. So delta Vx is equal to 1 meter per second. Now the relative velocity in the y direction, so delta Vy, that is Vy2 minus Vy1, so 2 minus root 3. So ultimately it will become delta Vy 2 minus root 3 meter per second. Now we have to find out if this delta y and delta x both are moving. This is in y directional component and this is the x directional component. So now we have to find out the angle theta. So theta, tan theta is equal to delta Vy divided by delta Vx. So theta is equal to tan inverse delta Vy divided by delta Vx. So here theta is equal to tan inverse 2 minus root 3 divided by 1. So from the logarithmic table, theta, that is tan inverse 2 minus root 3, the tan inverse 2 minus root 3, that is 15 degree. That is from the logarithmic table. So tan inverse 2 minus root 3 will become a 50 degree. So here ultimately we have to find out if both the balls are start moving from some point, the angle between their paths. So it is an angle between their path. So this is in y, and the resultant angle, that is 15 degree. This is delta Vx, and this is in the direction of delta Vy. So this is the theta angle, 15 degree. Thank you.